Hello friends, welcome to this session on Hazelcast caching solution. At the beginning, I would like to say two things. Number one, this video is ideally for everybody who wants to know more about Hazelcast and or for that matter, any caching solution because Hazelcast is definitely one of the best caching solutions around. And second is, I have been fortunate to use Hazelcast for some time in my career and I have collated my understanding and my learnings about Hazelcast for this video. And so I sincerely hope that you will be benefited if you watch this entire video. So with that said, I'm Shamik, who is a software consultant and developer who will be presenting this session. In this session, we are going to actually understand in a nutshell what Hazelcast is and why should we care about that. So what is Hazelcast? Hazelcast is basically a distributed key value store or a data grid, an in-memory data grid. It is exactly not a database in the sense that it does not persist data. So if you restart Hazelcast, it will lose all the data because it does not persist anything to the disk. But it retains the data in memory, and that is why we call it an in-memory data grid. So what is a perfect use case of Hazelcast? It is ideally used for caching any kind of static content or any kind of reference data. So any kind of data which you want to cache for your application means that data does not change so frequently with time. Like it may be some kind of reference data like list of countries, list of currencies, or it can also be customer specific data like account details or whatsoever, but which does not change frequently. Then you can ideally store this data in a Hazelcast cache. And what is the advantage of using Hazelcast cache over a relational database like MySQL or Postgres? Is that since Hazelcast stores the data in memory, it is much faster to store the data, to persist the data, or rather to store the data and to also retrieve the data from the Hazelcast cache. Again, it is not about Hazelcast is better than RDBMS or RDBMS is better than Hazelcast. It is all about in the case of a caching is required, then Hazelcast may be a leaner alternative to cache the data temporarily than storing in RDBMS, which takes a bit of more time to store the data. So with that said, let us go further to understand more details about Hazelcast. So in this slide, we are going to see how normally the production setup of Hazelcast is. I would like to keep this at a high level because this is really a very introductory video of Hazelcast, and in this video we are not going to delve into the details of a production setup, but also as a developer or as an architect who is developing an application which uses Hazelcast, we really need to know how the production setup looks like. So normally in a production setup of Hazelcast, we will have multiple systems or multiple nodes of Hazelcast where Hazelcast is running in every single node, and some data is stored and replicated in every single node. So it is like a standard distributed architecture, and in each of the nodes Hazelcast is actually installed, and also the Hazelcast Management Center is installed to create the cluster of Hazelcast. And I have also seen that in many production scenarios, often two Hazelcast clusters are created, one an active cluster and the other a failover cluster. Now in each of the active and the failover clusters, there are multiple nodes which are used to form the cluster and to actually take into account, to actually address the availability and scalability requirements. So that is about how a production setup of Hazelcast is done. Now we are going to see how we can actually easily replicate a development setup. Now there can be multiple options. One option is to have a Dockerized setup. So if you are used to Docker containers, then you can run basically a Docker command to actually bring up a Hazelcast locally in your in your laptop or in your MacBook. Or else there is an even easier alternative, which is running a standalone Java program. And why I'm saying it is an easier alternative to Dockerized setup is if you already have Java installed in your system, then it is essentially a one-liner program which is required to run Hazelcast locally. And how can we access a Hazelcast which is running, say, either locally or in a cluster within the network? So there are multiple ways in which we can access Hazelcast. One is a command line client. So Hazelcast ships with a command line client, which we normally use for administration. The next type of client, which is the most frequently used way to access Hazelcast from your application, is the native client. So Hazelcast provides native client libraries in multiple programming languages, including Java, Python, JavaScript, Golang, and maybe also some other languages. And this native client is basically the standard or the most recommended way or the most widely used way to access Hazelcast from within an application. So of course, if you have an application written in Java, you will use the Java library. If you have an application using Python, then you will use the Python library, and same goes for other programming languages. And also Hazelcast provides REST client, which in my opinion is really the kind of last resort if you are developing an application in a programming language where Hazelcast does not have a native client. Or if you have preference for REST invocation, then you can also go for it. So these are the different ways of accessing Hazelcast from a client perspective. Now, I'm going to briefly discuss about the different kind of caching patterns which I think all system developers, all software developers and architects definitely need to know in order to best use the caching provider in their applications. So the three different caching patterns are cache aside, read through cache, and write through cache. There are in fact even more patterns, but these three are kind of most widely used. And out of that, I would say the first one that you see on top right, which is the cache aside pattern, is the most widely used. What is that? In that pattern, we are actually, our application code, be it written in Java or Python or any other programming language, is responsible for syncing the data between the cache and the backend system. And in the other two patterns, like read through cache or the write through cache, then the responsibility of syncing the data between the Hazelcast or your cache provider and the backend data store is actually not with the client application, but with the cache provider. So I've tried to actually explain that in a diagram where on the left hand side you can see the cache aside pattern, where the app is responsible for first checking the data if the data exists in Hazelcast cache. If not, then it retrieves the data from the database or from any other backend system. It may not be a database, it may be an external service also. And on the right hand side, you can see the read through or the write through cache, in which the application is only interacting with Hazelcast, and Hazelcast is actually responsible for syncing the data with the database. I normally say that cache aside pattern is the most convenient caching pattern. The main reason behind that is if you decide to change your caching provider from Hazelcast to Redis or to Riak or to some other caching provider, then actually there is a lesser change of your code. But also on the other side, the cache aside pattern has its own. If you're using the cache aside pattern, you will have to take care of the fact that if for some reason there is a lack of synchronization between the database and the cache store, then you need to actually account for that. That said, let us take a Hazelcast demo where where we will see how Hazelcast basically works. How can we set up a very small dev setup of Hazelcast, and how can we interact with that. So I would suggest you to go to my repo, which is mentioned here, the link mentioned here, and read the README file and download the prerequisites, Java, Maven, and an IntelliJ, and run the programs. I'm now going to show a short demo of how this is done. So let's start with the demo now. I have downloaded the project and loaded up in the IntelliJ IDE, and on the left hand side you can see the project structure. One main thing to notice here is there are two subfolders here. One is a server and the other is the client. Within the server folder, this Hazelcast server is the server-side Java program to start a Hazelcast server, and within the client folder there are two programs which represent Hazelcast clients. So let us first start the Hazelcast server, and then we will start Hazelcast client and see how from Hazelcast client we can access the Hazelcast server. So let us click this. This is the single liner Hazelcast server program. We will click here to start this, and this should start the Hazelcast server locally. So it is starting the Hazelcast server, as you can see. It's starting the Hazelcast server, and it has started the Hazelcast server here. Now, before we go to the program within the client folder, there is another very basic client here, basic caching demo. Here we are actually getting, so this is also a very simple client program where we are getting first an instance of the Hazelcast server via this code here, and then we are creating a cache map here. IMAP is a very specific data structure within Hazelcast which represents a cache map. It's something similar to a map data structure in Java, or to a Python data structure, to a dictionary data structure in Python. And in this map data structure, we will first set a value named test-value to a key named test-key, and we will set it for 10 seconds for the cache to last, and we will see within 10 seconds if the cache stays, and then we will sleep for 12 seconds, and then we will see if the cache still stays. So let us run this program. We will first see that it connects to the Hazelcast server, and then it first sets the cache, and immediately the cache exists, so that's why it has received the value. But after sleeping for 12 seconds, we will see that the cache does not exist anymore, because this time, which is known as the time to leave period, has expired, and hence after 12 seconds the cache value will be null. So this is a very important thing to know about the Hazelcast solution, that there is a maximum time which is there for till which the cache will actually exist in memory. Now let us go to the more sophisticated client programs which are in the client folder, the typical way in which we will be using Hazelcast from within an actual application. So this cache service IMPL is basically a representation of how we will use Hazelcast from within the client program, from within our Java application. And the backend service is typically an example of a backend service. The cache service IMPL tries to retrieve the data from the backend service. So in this program, we will see also that this cache service IMPL program, it connects to the Hazelcast using similar syntax, and then it tries to get the profile data first from the cache. So it checks if the map contains the data, and if it does not contain the data, then it fetches the data from the backend, which is this, and then sets the data back in the cache so that the next invocation can use this data. Similarly, when I'm updating the profile data, it is first updating the cache as well as, it is first updating the backend, and then it is updating the cache. So this is a typical example of a cache aside kind of pattern where we are trying to read the data from the cache as well as to write the data to the cache as well as the backend. So that's it. One is a performance verification. So in a personal test bench, I have actually tested the performance of Hazelcast versus a very standard RDBMS like MySQL, where I have tried to insert some 1,000 records into a relational database versus similar 1,000 records into Hazelcast. Of course, as you can understand that a relational database persists or stores the data permanently in disk and Hazelcast does not. So it's not an apple to apple comparison, of course, but just for the sake of it, like the time it takes to insert is approximately, I have seen that for 1,000 records in the same machine, a relational database where it takes around 22 seconds to insert some 1,000 records, that too in a batch, but Hazelcast takes around 7 seconds to insert 1,000 records. Again, we are not saying here that RDBMS is bad or Hazelcast is good. We are just saying that Hazelcast can write faster, or Hazelcast can accept writes faster because it persists it stores the data in memory, whereas RDBMS stores the data in the disk. Next point that I want to mention is Hazelcast versus some other key value stores which you can consider for caching. So instead of going into the discussions about other key value stores, I would like to present a couple of things where, or a couple of areas where Hazelcast may be a better choice. Number one is, normally I have seen that if the application which is accessing Hazelcast is written in Java, then Hazelcast is probably a more natural choice because Hazelcast is also written in Java, and Hazelcast has got some kind of listeners which can be more relatively easily accessed from within Java. And also, if we want to leverage the read-through or the write-through caches, as we have discussed a while back, then Hazelcast may be a better choice because Hazelcast has native support for both this. And finally, I would like to share with you some of my key takeaways about Hazelcast, which have been learned over time. Number one is it's a distributed in-memory data grid, and the distributed nature prevents single point of failure, which means it is spread across multiple systems. So even if one or multiple nodes fail, then even after that, your data can still be accessed via other nodes. So it's a distributed solution. And second is, while using Hazelcast, we can and we should judiciously use the TTL or the time to live concept for different kinds of caches. And we can have different kinds of caches in Hazelcast for a particular application, and different types of caches can have actually different time to live. Say, for example, a cache which contains a list of all countries or currencies can have a much longer TTL. The TTL can be a month time, whereas some customer specific data like customer profile data, we can keep the TTL to a day. So since Hazelcast provides the advantage of being able to specify the TTL per cache, so we can actually use that TTL judiciously. Third point is something which I already mentioned in the previous slide, is Hazelcast does provide the option of read-through and write-through caches, which can be explored. And finally, on the pack ELC side, Hazelcast is mostly a PA/EC system, which means during stable scenarios, which means when the node does not go down, it leans towards consistency. It leans towards providing you with the latest data. So that is why it's a very critical thing to understand that if from a caching solution we want consistency, which means we want to get the latest data, then Hazelcast is something which you can consider, because Hazelcast leans towards consistency, but also that means that it will have higher latency. So now we have reached towards the end of this session, and I sincerely hope that you have liked the session. And if you have really liked it, I would humbly like to request you to subscribe to this channel, and also to share this video with your friends or whoever you think would actually benefit from this, because as you can imagine, that would really help me, that would motivate me to produce more useful content in future. Thank you very much.